Well, hello there. Mr. Bucko here with problems number 5, 6, and 7 from your Geometry Chapter 1 self-test, where 5, 6, and 7 we are asked to graph an inequality and determine if the picture that is drawn is a line, a ray, a line segment, or neither, or none of them. So the first one we have is number 5, where we have the inequality x is bigger than negative 5 and x is less than or equal to positive 2. So I'm going to graph this inequality on the number line here. I'm going to start with negative 5. And x cannot be negative 5 because there's no equal to. So we're just going to leave an open circle at negative 5. So this is the limit, but x cannot actually be negative 5. If we go up on the other side, or up to 2, x can be 2, and that's the biggest thing x can be 2. So I'm going to color that circle in because x can be equal to 2, so we're going to color in the circle. And then again, that might make it more obvious why this one's not colored in, because x cannot be equal to negative 5. And x has got to be bigger than negative 5 and less than 2. So those numbers are right in between those two dots, or the two circles that we have. So x can be anything along this solid black line and then up to 2. It cannot be negative 5. So what is this thing that we just drew? Is it a line? Is it a ray, a line segment, or is it none of them? It can't be a line because it doesn't go on in both directions forever. It goes to 2 and then it stops. If it was a line, it would continue to go all the way down to the right, and it would continue to go to the left. So it's not a line. It's also not a ray because it doesn't go in one direction forever. It doesn't start at a place like at 2 and go in this direction forever because it stops somewhere around negative 5. And the same can be said about the other direction. It kind of starts here, which we'll talk about in just a minute, and then it goes in this direction, doesn't go forever because it stops at 2. So it's not a ray either. Some would say this is a line segment because it stops, or it starts at 2 and then it goes this way and it stops at negative 5, but actually this is neither. It's none of them. And the reason why is because of this open circle at negative 5. The starting point is 2. We can say it starts at 2. It can be 2. 2 is the definitive starting point, or you can say it's the ending point 2. But if we were to go to this side, well, where does it stop? Can't only say that it stops at negative 5 because it's not colored in. So then where does it stop? Does it stop at negative 4.9? Well, then what about negative 4.99? Well, then what about negative 4.99999? So this is neither because of the fact that it doesn't have a distinct stopping point at negative 5. It does stop. It doesn't continue to go. There is an end to this, but it's not at negative 5, and it's not anything that we can say this is what it is due to the infinite amount of numbers that are in between negative 4 and negative 5. So this is neither, and it's this open circle is the reason for that. Number 6, which is coming here in just a moment, I promise. As you can see my little, there it is right there. Number 6. We have y is greater than or equal to 4. So I'm going to find 4 on the number line. It is right here. And then y can be greater than 4. Notice again it's colored in because y can be equal to 4. And y can be anything that's bigger than 4, which is this direction. So now let's just look at this thing that's just been drawn with the solid circle and the arrow going to the right, because y can be anything going this way forever. This is a ray. It has a starting point right here at 4, and it goes on to the right forever. So that is a ray. Number 7, we have z is greater than or equal to 3, and z is less than or equal to 6. So I'm going to plot these two limits here. 6 is the upper limit, so I'm putting the solid 6 there, or the solid circle there for 6, because z can be 6. Then I'll put another one at 3, because that's the limit here. Z's got to be bigger than 3 and less than 6, anywhere in there. And now this, unlike number 5, both of these circles are colored in. So, and it has a starting point and a stopping point, or vice versa. So you can start or stop at 6, start or stop at 3. This is a line segment.